For this lesson, we're just going to keep simplifying the rational expressions like we did with lesson 1. So remembering that when we're doing this, we need to state the non-permissibles based on the factored form of the original rational expression before we simplified it. And we can only cancel out entire factors from the numerator and denominator, not just separate terms. So when I'm doing this, I'm going to start by factoring down the numerator and denominator as much as I possibly can. When I do that for the first one, in the numerator, I'm going to factor out a t, and then I have a difference of squares, 4t squared minus 9, which is going to become 2t minus 3, and 2t plus 3. In the denominator, the only factor I have is a common factor of t and a 2t minus 3. Now from here, I look at my denominator, and I can state my non-permissible values that t cannot equal 0 based on this one, or 3 over 2 based on the other factor in the denominator. Then I'm going to cancel out the factor of t from the top and the bottom, cancel out the factor of 2t minus 3 from the top and the bottom. I've fully divided out the denominator, so then I'm just left with 2t plus 3. And this is only possible if t cannot equal 0 or 3 over 2. Moving on to example B, I'm going to factor down, I should say, the numerator. I'm going to factor it down using decomposition to get 2x minus 1 and x plus 3. I'm going to factor the denominator using decomposition to get 2x minus 1 and x plus 1. Once again, I'm going to pull my non-permissibles just from the denominator, where x cannot equal 1 over 2 from the first factor, or negative 1 from the second factor. Then I can cancel out the common factor of 2x minus 1 from the top and the bottom. And I'm left with x plus 3 over x plus 1, where x cannot equal 1 over 2 or negative 1. And there's my solution. Moving on to example C, I'm going to factor the top and the bottom. When I factor down the top, I'm going to wind up with a plus 4 and a minus 2. And if I do the bottom doing inspection, then I get the 8 to the 4s from a squared times a squared. And then the two numbers that have a product of 64 but add up to negative 20 are negative 4 and negative 16. Now at this point, I can actually factor both of these again because they're just two differences of squares. So I'm going to state that it's going to be a plus 4 and a minus 2 over, the first one is going to become a plus 2, a minus 2 for the difference of squares, and the second one is going to be a plus 4, a minus 4 from the difference of squares. Now, because I have four different factors in my denominator, I have four different non-permissibles. A cannot equal positive or negative 2 or positive or negative 4. And then I'm going to cancel out. So if I take away the a plus 4 from the top and the bottom and the a minus 2 from the top and the bottom, I've eliminated everything or canceled out everything in the top. Anytime I divide everything out, then I'm just left with a 1 there. So don't forget that 1. That's where people get confused. So I have 1 over a plus 2, a minus 4, where a cannot equal positive or negative 2 or positive or negative 4. And there's my solution. Now, sometimes we'll have certain rational expressions where part of it is out of order, or it can make it look like there isn't a common factor when there actually is. So if I take this first example, c minus 4 and 4 minus c. Well, imagine that the c value was 6. 6 minus 4 is not the same as 4 minus 6. One of them is positive 2, one of them is negative 2. So they're not actually the same factor. So the first thing that I have to do is I need to rearrange the order here, because I always want my variable to be first. But I have a negative c. So I would say that if I have c minus 4, it's going to be over negative c plus 4. Now you might remember something like this from grade 10, where if the factors are the same but the signs are opposite, how do I change that? I pull out a factor of negative 1. And if I took negative c divided by negative 1, it becomes positive c. And if I took positive 4 divided by negative 1, it becomes negative 4. And now my two factors on the top and the bottom are exactly the same. Now, the fast way to think of this is anytime I need to change the order of a subtraction, so instead of saying 4 minus x, it needs to become x minus 4, all I do is I pull out a factor of negative 1, or I switch the sign on the outside. And then I'll wind up with something that's equivalent. Sometimes I'm asked, well, is this going to change my non-permissible? Well, if I took 4 minus c, and I said that that cannot equal 0, then negative c cannot equal negative 4, which means c cannot equal 4. If I take this new form, where I have c minus 4 cannot equal 0, then c cannot equal 4. So it actually does not change our non-permissibles at all. If I multiply or divide out just an entire negative, it's not going to change anything there. In both cases, c cannot equal 4. And then when I divide anything by itself, then I'm going to wind up with 1. But because I have a negative in the denominator, it's actually going to be negative 1. So all of this simplifies to negative 1, where c cannot equal 4. And there's my simplified form. When I move on to the next example, I'm going to factor it down. So I'm going to pull a common factor of 2p squared from the numerator, and I'm left with p minus 2. In the denominator, they're both divisible by 8, and I'm left with 2 minus p, and just like in the last case, as soon as I see that I have this problem where it's in the wrong order, then I can change the order of it, p minus 2, and then I just change the sign on the outside, or I pull it in negative. Once I've done that, then I can eliminate from the top and the bottom. I can divide the top and the bottom by 2, so that's going to be left with a 4. And I can say that this would be the same as p squared over 4. It doesn't matter where the negative goes. It can go in the top and the bottom, or just beside the fraction. Beside the fraction is the most common. And from here, looking at my original factored form, this is true as long as p cannot equal 2. When I get to my example C, then I can start factoring down right away, or I can rearrange this in descending order by degree if I want, and say that this would be equivalent to negative 4x squared plus 1 all over 6x squared minus 5x minus 4. And I'm guessing you can already guess because of what we've encountered so far. I can also say, well, I'm going to switch these to put them in the right order, and my x has never been negative, or my variable's never been negative in any of the examples we've done so far. So I'm going to change the order, keep it a subtraction, and then pull a negative out. Now, I still just have a difference of squares on the top, and I can fully factor down everything in the bottom by decomposition. So when I factor it, I am going to have negative 2x plus 1, 2x minus 1 when I do the difference of squares for the numerator. And in the denominator, I'm going to factor it down to 3x minus 4 and 2x plus 1. I'm going to eliminate the common factor in the top and the bottom. And I can say that this is going to be the same as negative 2x minus 1 over 3x minus 4. And this is true looking at the entire denominator before it canceled out, as long as x is not equal to positive 4 over 3 or negative 1 over 2.